Welcome to Brain Vision.
Hello friends, in this problem it is given mass center G of 3 kg wheel. The mass of the wheel is given 3 kg and radius 180 millimeter, that is 0.18 meter, is located at a distance 60 millimeter from geometrical center. R is given 60 millimeter, that is 0.06 meter. So you can see this is the center of gravity or center of mass. It is located at a distance of 60 millimeter from geometrical center. The centroidal radius of gyration of wheel is given 90 millimeter, that is 0.09 meter. As the wheel rolls without sliding, its velocity observed to vary. At given position, its angular velocity is angular velocity is 8 radian per second. Call it to be initial position 1. Calculate angular velocity omega 2 when geometric center and mass center G is directly above the geometric center. See, second part, we have to find a reaction at the horizontal surface at that instant. We have to find the reaction at horizontal surface at this position. Let us start solving it. This is initial position. I am redrawing the diagram. This is the position 1. Geometrical center C, center of mass G, and this is here R meter above to the ground. This is omega 1, 8 radian per second. Say, this is velocity v1 and here its weight mg will act. So this is the instantaneous center. when it rolls down and center of gravity lies just above the geometrical center. At this situation, this is C, this is G, here the weight of the body will act, and here it will be V2, and this is omega 2, and this will be instantaneous center, and this distance will be r plus r, that is 0.24 meter. V1 will be Vg omega 1. Value of Vg by Pythagoras theorem you can find. See here, this Vg you have to find. This distance is a small r. This is the radius. So you will get 0.06 plus 0.18 square. So V1 you will get 8 into omega 1 is 8, and on solving it you will get root of 0.036 meter per second. V2 will be 0.24 into omega 2. Position 1. Gravitational potential energy 0. Kinetic energy is half mv1 square plus half I omega 1 square. Mass is given 3 kg. Speed we have measured 8 into root of moment of inertia is m into k square, and radius of gyration is given 0.09 meter, and whereas omega is 8. So on solving it, T1 will be 4.2336 joule. This is kinetic energy at initial position, and this is the potential energy. Now for position 2, potential energy is weight into h. Weight is mass is 3, weight 9.81 into 0.06. So it would be 1.7658 joule, and kinetic energy at second position half mv2 square, half I omega 2 square. Mass is 3. V2 will be R into omega, that is 0.24 omega 2. I is m into k square, so 3 into 0.09 square omega 2 square. So on solving it, this value will be 0.09855 omega 2 square. Now applying conservation of energy from position 1 to 2. T1 V1 is equal to, in first position kinetic energy is potential energy is 0. T2, this is not 2, I have to make a correction. T2 is 0.09855 omega 2 square plus potential energy. We have calculated it's 1.7658 joule. By solving this equation for omega 2, so omega 2 you will get 5 radian per second. This is the answer of part A. Now for part B, we have to draw the free body diagram. This is C. This is centroid, a center of mass. Here the weight will act. Here normal m into n will act. And this is the reaction of the flow. Calculation of m into n, omega 2 square into r. Mass is given 3 kg. Omega 2 is 5 into 0.06. So it would be 4.5 Newton in downward direction. So N will be equal to plus weight. This is 4.5 Newton. Weight is 3 into 9.81. So N you will get 24.9 Newton in upward direction. That's all for it. Thanks for watching it.